Okay, so we'll continue on in our lectures, and on Monday we talked about I gave you an overall big picture idea of what statistics is about, and today we're going to start our venture into descriptive statistics, and before we even get there, we'll have to talk about the nature of data. Okay. Okay, and so we often gather data, and wish to organize it. Okay. Now, there's many ways to organize and set up data, but as far as an intro stats class goes, the most common way to organize your data is with a data table. Okay, and with a data table, what we do is every observation is in a row, okay? Or vice versa, every row represents one observation. Okay. And then every column, okay, will be a variable, okay? So every bit of information you gather for each observation, every piece of information we gather for each observation is put in a column. Okay, so these are called variables. Okay, or if we said every row represents one observation, we'll say each column represents column contains a variable. Okay, and so, for example, we might gather a sample of data, okay? Okay, again, a sample is a selection taken from a population. Okay, we might have a sample of data, and perhaps our sample will just be, a group of students. We'll say a group, we'll say 40 students that we have arbitrarily selected. Okay, and so we might gather different pieces of information. We might gather the student's name. We might ask for the student's age, maybe their height, maybe in inches. Perhaps we ask for their gender. What else? Perhaps their hair color, etc., etc., etc. Okay, so each of these things we've got different pieces of information, and so perhaps we have Alice is 19. She is 54. No, not 54. That's too short. 64 inches, and we'll say female, and has brown hair. Okay? And then we'll have Brett, 21, 71 inches tall, male, blonde hair, etc., etc. Okay? We would have one row for every single person, okay? And maybe we get a total of, we will have, if we have 40 students, we will have a total of 40 rows. One for each student. Just say this is stats 10 week 1 Wednesday. Okay. The number of rows, or the sample size, is always denoted by the letter n. Okay, so n is equal to our sample size, which will be the same as our number of observations or number of rows in our table. Okay, so in this case, we have n equal to 40. So each observation is that. Okay. When we're talking about variables, we often say that there are two types of variables. Okay, and there are more types of data, more types of variables, but as far as the intro class goes, we'll say there are two types . Two types of variables. We have numeric variables and categorical variables. So actually, let me start off with categorical variables. Okay, categorical variables, these tell us what type or what kind or some kind of, or a piece of information that categorizes our observations, okay? Or a piece of information that can be used to categorize. Okay. And on the other hand, we have numeric variables. And numeric variables will tell us how much or how many. Okay, so let me just flip back a page, and I'm just going to copy kind of the first row here. You don't have to recopy it in your notes. You can just go back and relabel these things. So let's just go through our different variables and say, what kind of variable is this? Okay, so hair color would be categorical, right? Okay, gender, categorical. Height, numeric. Age, numeric. Okay, name. Yeah, this is a special type of categorical variable. This is often called an identifier, and perhaps it's not really data, but just a way to identify each observation. Some people might say that. Okay. Now, a lot of these things, numeric variables can also be represented in categorical fashion. Okay, so numeric variables can be made categorical. So for example, age, we often think of age as a numeric variable, right? If I say, what is your age? You're going to probably respond with a number, okay? And this tells you how much, or you know, how much or how many, and I guess age would be how many years you've been alive, et cetera, et cetera. But age can also be turned into a category. So in the eyes of the law, if you're under 18, you are considered a minor, okay? You can't vote, you can't join the army, you can't, I don't know, do stuff. And then once you turn 18, then you are considered an adult, okay? And so here we have turned a numeric thing based on how much time you've been alive, and we've turned it into a category. You are either a minor or an adult, okay? So age can be made categorical. So for example, age can be minor versus adult, okay? Or if you've ever taken a survey, like a marketing survey, and they ask you for your age, often they'll put you in these, what they call demographic categories, and they'll say, are you 18 to 24, or 25 to 34, or 35 to 49, and they have these just kind of these arbitrary different age groups. So, you know, or perhaps, you know, we have categories of age, such as 18 to 24, 25 to 34, you know, 35 to, you know, I don't know what marketing companies use, but often there's different groups such as this, right? And the products that they market to this group will be different from the products that market to this group, right? So everything that's a little app on your phone that's often shooting for the 18 to 24 group, whereas, I don't know, more traditional desktop applications maybe at a higher age group or something like that. Okay, whenever you have a categorical variable, oftentimes we want to come up with a list of acceptable categorical values, right? So, and this is always a difficult thing to do, okay? Unless you're like the, you know, if you're the candy company and you're making Skittles, then, you know, the color of your Skittles, there's what, 6 colors? I don't know, okay? 6 colors of Skittles, and those are like your 6 acceptable categories, okay? But other things that are categorical variables, the list of defined categories is very difficult, right? Like we could do something, you know, like go to the parking lot and just say, okay, what are the different manufacturers of vehicles are there, you know? And then you can say, oh, okay, well, we've got Ford and we've got Honda and Toyota, and you know, and you can start listing off these things. And then you keep going around and you're like, okay, I think I've got them all. I've got like 35 manufacturers. And then you run into some car that you've never seen before, and you're like, well, do I have to make a whole new category for this? And sometimes you can just say, okay, well, we'll just take, you know, the 30 largest ones and everything, you know, like, let's say somebody imported a Renault vehicle from Europe or something. And, you know, you can just make a other category, right? You know, and it depends, you know, what thing we're looking at. Or, you know, gender as a category, that's, you know, it's more complicated than, you know, for a long time, we said just there's female and male as far as genders go, but, you know, as today we probably recognize that that's not sufficient to describe everybody. And so you'll have maybe gender nonconforming as another category, and maybe, you know, there's all sorts of all sorts of things. So deciding how many categories there are, right? How many categories of hair color are there? It's complicated, right? You go to the whatever hair coloring aisle, and there's like 60 different colors that you can choose for coloring your hair. And I think it's easy to just say, oh, there's black hair, brown hair, and red hair, and blonde hair, or something. But there's obviously more than that. So, you know, choosing the number of categories, this is complicated and controversial. You know, we'll say values that a categorical variable can take is complicated, sometimes controversial. Okay, let's try one more thing. Let's say I threw in zip code. Okay, and we asked Alice, what's your zip code? And she says, I live in 90210. Okay. I want you to think about this. Is zip code numeric or categorical? Okay, so we'll think, and so if we were truly running clickers, I would, oh, I don't know what I did. I think I closed out the session, but I would say this. Okay, all right. Who thinks zip code is numeric? Okay, what about categorical? Oh, okay, all right. Great. You guys all got it right. Okay, so zip code would be categorical because even though it's a number, it doesn't tell us how much or how many. It's something that we can use to categorize people. We're categorizing them by geographic location. So we can take, you know, when we send mail, we can just put all of the people in this location in a certain stack and give it to the mail carrier or the post office for that zip code. And it doesn't make sense to compare zip code values and say I have 20 more zip code points than you. Whereas comparing ages, you can say I'm 3 years older than you. That makes sense. Comparing zip code does not make sense in that regard. Okay, is this good? Okay, let me talk about gathering our data, okay? Gathering data. So as far as gathering data goes, there are a few ways, and so first we're going to just start off with anecdotal evidence, okay? Anecdotal evidence, these would be things like stories or customer reviews. These are things where it's like, you know, my aunt did this and and it cured her whatever, okay? Cured her arthritis. Okay, that would be an anecdote. Or even all of those Amazon customer reviews, right? You go on Amazon, you go on Yelp, and you read about people's experiences and what happened. Those are all anecdotal evidence. And it's, from a statistical standpoint, we can't do much with anecdotal evidence, okay? There's no real analysis methods that exist for anecdotal evidence, okay? So that's not to say that anecdotal evidence is not useful, because anytime I buy a product, before I buy it, I go on Amazon and I check to see these reviews, and I say, oh, what do people have to say about this, okay? Or, you know, before you, if you go to a new town that you're not familiar with, sure, I'll go on Yelp and I'll say like, oh, where do people like to eat? It's still useful, but as far as trying to do some kind of statistical analysis and say, you know, is this product better than this product because the average rating here is 4.4 stars and the average rating over here is 4.1 stars, it's a lot trickier, okay? We don't really have any kind of methods. And there's always the problem of fake reviews. There's always the problem of, you know, who are the people who choose to post reviews, right? Some people, every time you buy something online, probably they send you a thing and they're like, will you give us a rating? And you know, you can't download an app without it asking you to start giving it a rating after like using it for 2 hours. And you know, who rates every single app they download? I don't know. Some people do, right? And the people who choose to leave ratings may be more prone to give high or low ratings, and we don't really know these behaviors. It's hard to really parse out exactly what all these things do. But entire industries are run on customer reviews, right? I mean, Yelp needs this, but from a statistical perspective, we can't really do anything with it, okay? And then, you know, stories about your aunt fixing her arthritis with some strange method. We're not discrediting that. We're just saying statistically, it's hard to do much with that either, okay? So another way to gather data is observational studies, okay? With an observational study, we observe our subjects. Okay. Ideally, our selected subjects are representative of the population. Of the representative of the population, or at least a random sample. And we try not to interfere with our subjects other than taking measurements. Yes?
Well, I have a quick question about anecdotal evidence.
Sure. Question about anecdotal evidence. Go ahead.
So, would it make a difference if the review were from a person or if they were from a company like Consumer Reports, like that tested the product? And
Yeah. So a company that does reviews, right?
Yeah.
Or you know, there's like popular companies that review electronic products and things like that. That's still anecdotal evidence, okay? It's still just one person or maybe a group of people at this company, one organization, looked at this product, tested it out, and came up with some kind of thing. Now, a company might try to reduce a lot of this personal opinion stuff by having a little bit more of a systematic approach to it, but their final result, whatever it is still anecdotal, okay? And again, I'm not saying anecdotal evidence is useless, okay? And you have other sites that have now tried to aggregate these anecdotal things and try to come up with things like Rotten Tomatoes. It goes through other people's ratings of movies and aggregates them together. Metacritic does stuff like that. But again, it is just it's still what people are reporting. Now, because as these data sets get larger and larger, there's a question: do these anecdotal things merge into something? And it's not fully understood. And I don't want to dwell too much on this thing of anecdotal evidence. Okay, we're gonna, as far as our intro class goes, we're gonna talk about observational studies and then experiments, and these are kind of our main forms of data and things that we can do with. I guess there is this emerging field of dealing with anecdotal evidence, but it's a lot more complex because your traditional assumptions about these things no longer apply. So, okay. So ideally, our selected subjects are representative of the population, or at least a random sample. Yeah, we try not to interfere with our subjects. Other than recording measurements. And ideally, whatever research question we have, ideally we can gather information on all aspects that could be relevant to this research question. Okay, so ideally we can record all bits of relevant information. Okay, but of course that's not physically possible. Okay, you can't record everything about a person because at this, somebody might say, oh, we need to know a person's blood pressure at every moment throughout the day. We also need to know their heart rate, and we also need to know exactly what they ate. And I don't even know what I ate. And unless you have some kind of robot chasing after a person recording everything they do, you're not going to get all this information. And you'll be lucky if they come in to your office for measurements here and there and stuff like that. So ideally we can record all bits of relevant information. We probably can't. Okay, and at the end of the observational study, you might find variables that have associations with the outcome that you're studying. Okay, you might find that certain variables are associated with a particular outcome. All right. However, we can never make a cause and effect conclusion from an observational study. Okay. Okay, all we can say is that certain variables are associated with certain outcomes. Okay, so for example, maybe you did a study and you find at the end of your study you notice that people who had diets high in vitamin C contracted the flu at a lower rate than people who had diets low in vitamin C or something like that. Okay, and so then you might be tempted to say, oh, if you want to avoid getting the flu, increase your vitamin C intake. Okay, that would not be a good conclusion. All you can say is that in our study, we found people who had diets high in vitamin C were less likely to get the flu. It could be that people who had diets high in vitamin C also had diets that were high in vitamin B and K or something, and it's these other vitamins that are what's important for reducing their flu. Or maybe it's something completely different, okay? If it's just an observational study, we don't know if there's something else going on that is actually the reason that's causing something else, okay? So there could be what we call lurking or hidden variables that are responsible for the true cause. Okay, and an observational study will not tell you that, okay? It might point you in the direction for further study and investigation, okay? So you might be like, okay, well, this is interesting. Let's look further into it, okay? Observational studies are useful in that regard. But again, we can never make a cause and effect conclusion straight from an observational study. And, you know, for example, if you were to look at, you know, elementary school performance. Well, okay, actually, before I get into experiments, let me just give another example. If you were to look at elementary school performance and students in elementary school, and you looked at, you know, let's see, we're interested in, you know, what factors go into how well a student performs, you know, on their reading exams. If you did an observational study, you might find that households with more electronic devices being tablets and phones and TVs and computers and all of these things, you'll find that children that come from households with more electronic devices in general have higher reading performance than students were coming from households with very few electronic devices, okay? And this would be this is an actual, I think there was a study and they did find this thing. Does that mean the answer to help student reading performance would be to just give everybody some electronic devices and say, okay, this is now going to make us read better? No. And what's actually going on there? Okay, so we suspect wealth, okay, and somehow, you know, wealth has become this wealth and socioeconomic status we've accepted as saying this correlates with reading ability, and it's true that we have noticed that students coming from families with generally higher socioeconomic status tend to perform better in schools than students coming from families with lower socioeconomic status, okay? But there's another question there, which is there anything about wealth in of itself, money in of itself, that causes students to be better readers or less, or perform lower? And there's nothing inherently about money in of itself. Everything is much more complicated. And, you know, we can look at all sorts of things, and, you know, it could be that families with lower income have to live in neighborhoods where, you know, the school is less funded and they have, you know, less funding for education. Everything is quite complex, and so even though at the end we might just say, well, a lot of things are tied to income, that in of itself is not really a satisfying answer either, because as far as there's nothing inherent about income either. So it's complicated, and observational studies will find these relationships but will not tell you cause and effect, okay? On the other hand, we have experiments, okay? So experiments as a way to gather data, okay? Okay, and here we're particularly talking about controlled experiments. So in a controlled experiment, the researcher, ideally the researcher can control all aspects about the participants, okay? Let's just say ideally. Okay, and then the researcher assigns the treatments or which is a set of conditions to the subjects. Okay. And so the big idea is that everything about all of the subjects are identical with the exception of the treatment, okay? So in our ideal scenario, you have group 1 and group 2. We might call one the treatment and control. You know, everything about both groups are exactly the same. Okay, and then except there's one difference. Okay, group 1 gets treatment 1 and group 2 gets treatment 2. Okay, treatment 1 might be the control or the default. Okay, except one difference. Group 1 has treatment 1. Group 2 has treatment 2. Okay. We might call one of these the control group. Okay. And then, so if we observe a difference at the end of the study between the overall outcomes, okay, so then, you know, any difference in the outcomes at the end of the study at the end of the experiment, I should say, can then be attributed to the different treatments. Okay, so if the data support it, you can make a cause and effect conclusion with an experiment. The thing about experiments, though, is that not all experiments are ethical or physically possible, okay? So, you know, we might be curious, do carbon emissions from coal factories contribute to climate change, okay? And so there's a lot of research that supports this idea. But if we wanted to do an experiment, this is not physically possible, okay? Because we can't do large-scale changes and see what happens to the Earth, and that, I think people would have problems with that if we did something like that. Or, you know, on a smaller thing, like let's say we wanted to know, okay, what are the long-term side effects? You know, what are, you know, possible effects of long-term marijuana usage? Okay, we could ask for volunteers. But the way an experiment would be done would be we would put people into two groups, and we would say, okay, group 1, you are not allowed to go anywhere near marijuana. And group 2, guess what? Starting tomorrow, you're going to smoke some marijuana every single day for the next 20 years. And then we'll check in on you in 20 years and see what kind of effect this has had on you. Okay? That's how we would have to do an experiment. That is not ethically possible. And so right now, all of our information regarding long-term drug use or things like that is coming from observational studies. And there's a lot of questions that, you know, we cannot make cause and effect conclusions ultimately from observational studies. Okay, we'll end here, and we'll see you guys on Friday.